section 2.1, the rectangular coordinate system. We're going to start off just by kind of reviewing the whole XY axis system. Remember that the x-axis is the horizontal axis, the y-axis is the vertical axis. The point 0, 0 is called the origin. And then the quadrants are the part that a lot of people forget. Quadrants start here, and that's quadrant 1, and then they move counterclockwise. So quadrant 2 is over here, quadrant 3 is down here, quadrant 4 is over here. Counterclockwise. Also note that you don't use Arabic numerals. You don't use the symbol for 1, 2, 3, 4. They use Roman numerals. So if you're going to write quadrant 3, you would do quadrant, and 3 capital I's. That's how you would notate quadrant 3, not with just the symbol 3. So it's assumed that you remember a lot from Algebra 1, Algebra 2, and even earlier than that. So we're just going to hop right in. We're going to talk about graphing the line x plus 2y equals 5. There are several ways you can graph a line. You can graph a line by putting it in slope-intercept form, which I think is usually most students' favorite. You can graph a line by making a table, finding some x values, plugging those in, and finding the y's that pair up with them. And you can graph a line by finding the x and y intercepts. So you just tell me which way you'd like to graph this one.
Slope-intercept.
Slope-intercept form? Okay. So that means that we need to isolate the y. So if we start with x plus 2y equals 5, we get the y by itself. We'll move the x to the other side. So we have 2y equals negative x plus 5. And remember that with slope-intercept form, we usually put the x's before the constants. Divide everything through by 2. And that gives us y equals negative 1/2 x plus 5 over 2. Maybe you're regretting it now, huh? Is everybody okay getting to slope-intercept form? Okay. What makes this a little trickier than others?
Right. The graph.
The y-intercept is a fraction, right? But that's okay. We can just look at it as y equals negative 1/2 x plus 2.5. So I know that my y-intercept is positive 2.5. So the first thing I'm going to do is go to the y-axis and put a dot at about 2.5. So there's my y-intercept. From that y-intercept, I'm going to move the direction the slope tells me. The slope is negative 1/2. So that means I need to move down 1 unit and to the right 2 units. So down 1 to the right 2. And we could do that as many times as we want. Down 1 to the right 2. Until we establish a good pattern and we can connect the dots in a solid line. There's the graph of x plus 2y equals 5. If you had graphed it any of the other ways, you would have gotten the same line. You just might have had different dots to guide you, but it would have been the same line in the end. For our next example, we would like to graph 3 distributed onto y plus 2 equals 2x minus 3. First thing I'd like to do is distribute the 3 so that I have 3y plus 6 equals 2x minus 3. At this point, we have to decide, are we going to graph it again by slope-intercept form or by making a table? Slope-intercept form? Y'all really like that, don't you? I didn't learn that in high school at all. That was totally new to me. We always made a table. We made an XY table, and then we chose 3 to 5 x's, and we plugged them in and solved for the y's. I don't know how I missed the whole slope-intercept thing, but I did. That was not a big way of graphing back then. Slope-intercept form is nice, though, because once you get it in slope-intercept form, that's what you can put into y equals on your calculator and graph and check. So it's kind of nice that you guys always want to do that because you're in the habit of solving it for y, and that will allow you to put it into your calculator. So I guess we can go ahead and subtract 6 from both sides. And we have 3y equals 2x minus 9. And then divide everybody through by 3 for a final slope-intercept form of y equals 2/3 x minus 3. So that is slope-intercept form. From there, where do I put my first dot on my graph? At -3 on the y-axis. So -1, 2, 3, with a slope of positive 2/3. So from that point, I'm going to count up to 1, 2, and over 3. 1, 2, 3. I'll do that as many times as I can before I run out of room on my graph, just so my line will be a little straighter. 1, 2, over 3. And now I'm kind of out of room. So that gives me 3 dots right here. If I want to access any more dots down in this region, I can see the general trend. I can see that it's going to look like this, a line with a positive slope hitting the y-axis at -3. If I want to get over here and find another point, we just reverse our direction. Instead of going up 2 and right 3, we go down 2 and left 3. And we could do that as many times until we run off the edges of the graph. And then we connect the dots, preferably with like a straight edge or a ruler, but we kind of get lazy, so make it as straight as you can. Connect the dots, and be sure that you put arrows on the end. What are the arrows for?
Forever.
They indicate that it isn't a line segment, that it's a line, and it keeps going in that direction forever and ever. So it continues to expand and hit infinitely many points. So we've already talked a little bit about the y-intercept because we can see that when we solve for y, we can actually see the y-intercept pop up. But let's talk about the definition of intercepts. Just generally speaking, intercepts are points. That's the first thing you need to understand. They're points. They're not singular numbers. They are an ordered pair. 0, 5, -3, 0. They are a point. So don't tell me the intercept is 3 or -5. Give it to me as an ordered pair. That's the first thing. They are the points where a graph, any graph, doesn't have to be just a line, even though we're studying lines right now. It's where any graph touches either one of the axes. That's called an intercept. If it touches the x-axis, it's called an x-intercept. If it touches the y-axis, it's called a y-intercept. So up here, the y-intercept is any point of the form 0, b, where the x value is 0, but the y value is a number. That is another number. Well, actually, it doesn't really matter. I mean, you could have a 0 y-intercept as well. So any point where the x value is 0. And that, to me, is more useful than what all is saying up here. So let's just kind of like break that down a little bit. The y-intercept is a point where x is 0. To find the y-intercept, simply substitute 0 for x and solve it for y. Let x go to 0, solve it for y. And that will work for any equation. If you want to find the y-intercept, that's how you'll do it. Likewise, to find the x-intercept, that's any point where the y value is 0. So to find those, we're going to let y equal 0 and then solve for x. We will use this concept of intercepts for the remainder of the semester. So make sure you latch onto it, you don't get them backwards, and that you're very comfortable with how they work. For example 3, we're going to specify that we want to use the x and y intercepts to graph the equation 3x plus 2y equals 12. We'll talk about this in greater detail later on, but this equation is in what we call standard form. And we can easily convert it to slope-intercept form, but that would only tell us one intercept. That would tell us our y-intercept, and we would still be out there looking for the x-intercept. So the easiest way if you're in standard form, if you just want to get both intercepts, is just to let one of the variables go to 0, then turn around and let the other go to 0 and solve them. So we're going to find the y-intercept first. To find the y-intercept, we are going to let x be 0. So we'll have 3 times 0 plus 2y equals 12. So that means that I have 0 plus 2y, which is just 2y, equals 12. And the y value of the y-intercept is 6. Sometimes your book calls that little b. So the y value is 6, which means the actual intercept is 0, 6. X is 0, y is 6. So that's one of the points we're going to put on our graph. Let's go now and try to find the x-intercept. The x-intercept is the point where the y value is 0. So I'll keep the 3x and I will substitute in the place of the y a 0. So 3x plus 0 equals 12, which means that 3x equals 12, and x must equal 4. So the x value of our x-intercept is positive 4, meaning our point is what? 4, 0. And those are the 2 points I'd like to come over here and put on my graph. Be careful that you don't get them backwards. A lot of people get in a hurry. 0, 6 starts at the origin, doesn't go anywhere horizontally, but moves up 6 units. 1, 2, 3, 4, 5, 6. 4, 0 starts here and moves 4 units horizontally, 1, 2, 3, 4, and nowhere vertically. So there are the 2 points, the x and y intercept. Connect them. You can see I really should have used a ruler. Put your arrows on the end. And that's the line 3x plus 2y equals 12.
So you do want to start that from standard form?
It's easiest to find intercepts from standard form. It's less work. But it's not impossible to do it from other forms. It's just that if you already have standards, that's a good choice to make if you get to choose which way you graph.